All right, this is 6.4, part B of this lesson, translating sine and cosine functions. So we just got done talking about how to graph the sine and cosine functions, and here I have graphed for us already one period of the sine function. Remember, going from 0 to 360 degrees. Sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, and sine of 360 is back at 0. That's one period. Now, what if, similar to, we've done translating transformations earlier, so, what if I had something, if you notice this has a 1 out front, so what if I had something 3 sine x? Well, all that does, it's literally growing 3 times quicker, so the amplitude of the sine function is not 1, but 3. So this would literally go up to 3 and down to -3. It still looks exactly the same. But notice the sine function would start at 0, but the amplitude is being multiplied by 3. Kind of like if you're recording yourself and you talk really loud, then all of a sudden the amplitude rises. Well, that's really what you're doing. It's going higher up. It's going up to 3 at 90. So 90 is 3. And then going back to 0, then down to -3, and then back up to 0 again. So again, the number on the outside, that's the amplitude. And that just tells you how high the graph is going. Again, normally there's a 1, so it just goes to 1 and -1. The unit circle goes to 1. So if this 3 basically means it's not a unit circle, but the radius would actually be a 3 length. Okay, so this would be 3, 0. 0, -3, -3, 0, and then 0, -3. Okay, so that's really all it means. Now, I could also transform, that's the amplitude and number on the outside. So remember, if we had a function, here's the sine function, but we also could literally add something like +4 on the outside. Well, that +4 is going to raise it 4 spots. Okay, so the normal, let me stay with 3 as well. So if I have the normal sine function starts at 0, okay, I'm going to do that in 0. Now let me do the exact same thing, goes up to 3, goes to -3. That's the normal sine function, you can see that. But notice it's starting off 4 higher. So, let me back up just so it's a smaller number, can fit in my graph. So what if it's just +1? So instead of starting here at 0 and going up to 3, it's actually going to start at 1. This is 1. So it's going to start at 1, and it's going to transform. It's literally going to lift this one space higher. So literally, it's going to take that point, and it's going to lift it 1 space higher. It's going to take that point and lift it 1 space higher. So literally, it's going to go up to 4. Okay, and then it's literally going to go exactly the same thing. Instead of coming down to 0, it's going to come down to 1. All right, so it's going to go from 0. Normally you have 0, 0, but here you're going to have 0, 1 because it's being lifted up 1 spot. And then at you still have the 90, you still have the 180, you still have the 360, 270, and then you still have the 360. Okay, so at 90, it's up here at 4. And then at 180, it's down here. And then it's being shifted, because it got shifted up 1 spot, it's actually only going down to -2. So it's the same function. Okay? It's still amplitude of 3, but it got raised up 1 spot. So it's, again, taking this same function, but it's raising everything up 1 spot. And then lastly, the other thing that could actually happen if I have the sine function, but I want to, say, shift it 90 degrees. Okay, and again, we're doing the opposite of that, so it's going to be shifted 90 degrees to the right. So 90 degrees to the right. This is just the plain sine function. There's no amplitude other than 1, so it's just going up to 1, but it's being shifted 90 degrees. So again, here's the normal function you can see right here, okay? That's the normal function, but everything's going to be shifted 90 degrees. So you're going to be doing 90, and that's going to be my, like this is your starting spot, but this is going to be shifted 90 degrees over. And then you still have, you're going to count by 90 degrees, okay? So this is going to be 180, and then 270, then 360. And then notice you still need to add 90 more to that, 50. I'm running out of space here. But you're going to literally, because you shift it, it's going to go up here. We're just doing an amplitude of 1. Here, 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 and then back to here. It's still the same sine function, but everything got shifted to the right 90 degrees. And I want to emphasize, this is just one period that I'm graphing, okay? So remember that, just one thing I want to emphasize to you, that this keeps going on forever, okay? So if I tell you to graph just one period, or 2 periods, or 3 periods, then you need to, follow the directions because I'm just graphing one period on these illustrations. And then likewise, the same thing with the cosine function. So the cosine function could, this is the original cosine function. I could add an amplitude to it, just like I did last time. It's going up to 3 instead of that. I could raise it, so I could do cosine of x plus 1, just similar to the last time. And then I also could shift it 90 degrees to the right. Okay? So you can have an all-inclusive formula, something like this. It could be something like 3 cosine of x minus 90 plus 1. So notice that right there, you have all 3 of them. The amplitude of 3, so it goes up to 3, but it's starting 1 higher, and everything's being shifted 90 degrees to the right. Okay, so there's 3 things going on, just like the transformations that we've done already. This is the same thing with sine and cosine functions as well. That's graphing sine and cosine functions and then their transformations.